Hello everyone. Welcome to another episode of Deep Dive Knowledge. Hello. I understand that you have written a report on remote sensing and GIS. I'm interested in learning more about this topic. Could you please provide me with a brief overview of your report and its main findings?
Certainly. In our report on remote sensing and GIS, we explore the use of remote sensing technologies and their applications in GIS. Geographic Information Systems. The report covers various topics such as the definition and principles of remote sensing, different remote sensing technologies, and their role in GIS applications. One of the main findings of our report is the significance of remote sensing in capturing data about Earth's surface without direct physical contact. This allows us to obtain valuable information about land cover, vegetation, climate patterns, and other environmental factors. Remote sensing data can be collected using satellites, aircraft, or other platforms equipped with sensors. Furthermore, our report highlights the integration of remote sensing with GIS, which enables the analysis and visualization of spatial data. GIS helps in organizing, managing, and analyzing remote sensing data, allowing us to make informed decisions based on this information. The combination of remote sensing and GIS has proven to be a powerful tool for applications such as land cover mapping, environmental monitoring, disaster management, and urban planning. Overall, the main takeaway from our report is that remote sensing, when coupled with GIS, provides valuable insights and solutions for a wide range of fields. It allows us to better understand and manage our environment by providing accurate and up-to-date spatial information.
Thank you for providing an overview of your report. It sounds like remote sensing and GIS have significant applications in various fields. However, I'd like to challenge the validity of these technologies. While remote sensing may provide valuable insights and information, are there any limitations or challenges associated with it that may affect the accuracy and reliability of the data collected?
Yes. There are several limitations and challenges associated with remote sensing that can affect the accuracy and reliability of the data collected. Some of these limitations include 1. Spatial and temporal resolution. Remote sensing sensors have limitations in terms of their spatial and temporal resolution. Spatial resolution refers to the level of detail that can be captured in an image, while temporal resolution refers to the frequency at which images are acquired. Lower spatial resolution may result in the inability to distinguish smaller features on the ground, and lower temporal resolution may lead to the inability to capture rapid changes in the environment. 2. Atmospheric conditions. The Earth's atmosphere can affect the quality of remote sensing data. Atmospheric particles, such as dust and pollutants, can scatter and absorb the electromagnetic radiation captured by sensors, leading to errors in the data. Additionally, clouds can obstruct the view of the Earth's surface, limiting the availability of cloud-free images. 3. Sensor limitations. Different sensors have different capabilities and limitations. Some sensors may be more sensitive to certain wavelengths of light, while others may have limitations in detecting certain types of features or phenomena. It is important to understand the characteristics of the sensor being used and how they may affect the data being collected. 4. Data processing and interpretation. Remote sensing data often require processing and interpretation to extract meaningful information. This process can introduce errors and uncertainties. Factors such as the choice of algorithms, calibration techniques, and the expertise of the analyst can influence the accuracy and reliability of the derived information. 5. Data availability and accessibility. Access to remote sensing data, especially high-quality data, can be limited and expensive. Some areas of the world may have limited coverage or availability of data, which can affect the reliability of analyses conducted in those areas. Additionally, data from different sensors or sources may not be easily compatible or readily available for integration and analysis. Overall, while remote sensing is a powerful tool for collecting information about the Earth's surface, it is important to be aware of these limitations and challenges to ensure the accuracy and reliability of the data collected. Researchers and analysts need to carefully consider these factors and apply appropriate techniques to mitigate potential errors and uncertainties.
Thank you for addressing the limitations and challenges associated with remote sensing. It's important to be aware of these factors to ensure the accuracy and reliability of the data collected. In your report, you mentioned the integration of remote sensing with GIS. Could you explain in more detail how GIS is used in conjunction with remote sensing data? Specifically, how does GIS help in organizing, managing, and analyzing remote sensing data to derive meaningful insights and solutions?
In the report, it is mentioned that GIS, Geographic Information System, plays a crucial role in organizing, managing, and analyzing remote sensing data to derive meaningful insights and solutions. Let's break down how GIS helps in these aspects. 1. Organizing. GIS provides a framework for organizing remote sensing data by storing it in a spatially referenced database. This allows for efficient storage and retrieval of large volumes of data. GIS software allows users to create layers of information, such as satellite imagery, aerial photographs, and other geospatial data, which can be combined and analyzed together. 2. Managing. GIS enables effective management of remote sensing data by providing tools for data manipulation, integration, and quality control. It allows users to pre-process and clean the data, ensuring accuracy and consistency. Additionally, GIS software offers functionalities for data integration, allowing users to combine remote sensing data with other spatial datasets, such as topographic maps or land use data, for a more comprehensive analysis. 3. Analyzing. GIS provides a wide range of analytical tools that can be applied to remote sensing data. These tools allow users to perform various analyses, such as image classification, change detection, and spatial modeling. For example, with GIS, one can classify satellite imagery into different land cover classes or detect and analyze changes in vegetation over time. GIS also supports spatial analysis, allowing users to perform proximity analysis, View-sht analysis, and spatial statistics on remote sensing data. By integrating remote sensing with GIS, users can visually explore and analyze the data in a geospatial context. They can overlay multiple layers of data, perform spatial queries, and generate maps and reports based on the analyzed results. This integration enhances the understanding of complex relationships and patterns within the remote sensing data, ultimately leading to more informed decision-making and solutions to real-world problems.
Thank you for explaining how GIS helps in organizing, managing, and analyzing remote sensing data. It seems that the integration of remote sensing with GIS provides a robust framework for extracting valuable insights from the collected data. In your report, you mentioned that various satellite sensors are used in remote sensing research. Could you provide some examples of these satellite sensors and highlight their specific applications and capabilities?
There are several satellite sensors used in remote sensing research, each with its own specific applications and capabilities. Two examples of satellite sensors are the AVHRR, Advanced Very High Resolution Radiometer, and Landsat MSS, Multispectral scanner. The AVHRR sensor, which produces 1 km multispectral data, is used primarily for mapping large areas when good temporal resolution is required. It has 4 or 5 spectral bands that can be used for various applications such as snow cover and vegetation mapping, flood and wildfire monitoring, regional soil moisture analysis, and geologic applications. The spectral bands of AVHRR include visible red, near-infrared, infrared, and thermal infrared. Its spatial resolution is 1 km. The Landsat MSS sensor, which was used on the first 5 Landsat missions from 1972 to 1993, provided continuous and comparable data over a period of about 20 years. It has a panchromatic band with 15 meters spatial resolution and a spectral bandwidth from 0.52 to 0.90 micro-m. One of its notable features is the thermal band, which has a spatial resolution of 60 meters, an improvement from the previous 100 meters resolution. The Landsat MSS sensor has been used for various applications including land cover mapping, change detection, and environmental monitoring. These satellite sensors, among others, play a crucial role in remote sensing research by providing valuable data for studying and understanding the Earth's surface and its changes over time. They enable researchers to analyze and monitor various environmental phenomena, contributing to fields such as agriculture, forestry, climate change, and natural disaster management.
Thank you for providing examples of satellite sensors used in remote sensing research. It's interesting to see how different sensors have their own specific applications and capabilities. In your report, you mentioned the different electromagnetic bands used in remote sensing. Could you explain in more detail how these electromagnetic bands are utilized and what specific information can be derived from each band?